In the day-to-day operational tasks of a Linux-based environment, how do you know which boot the system is running? What is the type of bootloader? Are we using the older legacy BIOS booting? Are we using the UEFI, the newer booting method? Let's find out. We have here two systems. One is installed with the legacy style booting, which is called BIOS legacy. The other is installed with the newer UEFI booting method. How do we find out which one is which one? So there is a few ways of determining which one is what is which one. The first thing it will come to mind is to find out what type of disk are we having. Let's find out the boot location first. The first indication of the boot is this convention. Typically the newer UEFI installation comes with a combination of boot EFI folder plus /boot, or inside the /boot, more conventional style XFS. The EFI is typically made of FAT type for Windows compatible installations as well. So this is the first thing to find out what type of boot is this. So let's find out where is these two UUID locations pointing at. So start with 60A, which is SDA disk, and 101, which is SA2 disk. So let's find out what the SAD is, what type of disk is. So we can see here, it is very important to note that UEFI are now have to be partitioned as in a GPT style. Also, let's check if the kernel has loading UEFI code. As we can see, there is variables loaded by EFI code on the kernel. So now let's switch to the second system and find out the differences. This is the other disk. Let's find out the boot. This is just one partition, very traditional. It also points to disk SDA. Let's do that again. SDA as the boot partition we found in the fstab loaded into the system. Let's find out what type of disk is this. So we can see the difference, the main difference being the partition method or table is SMDOS. That's what identifies the legacy boot. So that's a few. By comparison, let's also check at the code loaded by the kernel and see if we have EFI code, which we don't. Let's now move to the MBR. So as it is explained, the MBR is stored on the first sector of your hard drive, sector 0. As we can see here, if we have a sector of 512, typical sector size of 512 bytes, then we would have it on the first sector, and then we would have second, third, and fourth sector. That would be 2048 sectors free, or bytes free or reserved for this operation. 1, 2, 3, 4 sectors. The first one taken by the MBR, and this one apparently I'm going to say they are reserved. I don't know, I have to double check what it is or search online, but I believe they are reserved up to the first usable sector by the partition. So they are clearly not part of any partition. The first partition of the disk, whether is the traditional BIOS legacy MS-DOS partition type or GPT type, they would start at the 2048 byte, or in other words, the fifth sector. The MBR is a special code that is installed at the first sector of the disk. First sector of the disk. This is done in either MS-DOS partition or traditional boot legacy, and also the newer GPT disk. The traditional MBR, the older MBR, the older BIOS legacy disks only allows for disks up to 2 terabytes in size and 4 primary partitions. The GPT disk allows to manage disk higher than 2 terabytes. So newer installations of Linux systems are typically now coming with UEFI bootloader instead of the legacy ones. But this is the way we find out the one or the other. Very useful tool to also provide information about the MBR and the type of partition of the disk is GDisk, which is the newer F-disk for GPT systems or UEFI systems, but it also compatible with older legacy as well. So let's find out what information it gives us from SDA. In this BIOS legacy system, it shows that it is found MBR only, and there is no GPT. So this is also another good indication that we're only running a system with a legacy BIOS boot. Also, it shows us that the sectors of the boot SDA1 partition starts at the 2048 sector. This will be the fourth sector. The size of each sector is 512, so times 4 would be 2048 bytes. The MBR is installed at the first sector, meaning that it is spanned from 0 to 512 bytes, with the other 2, 3, and 4 sectors reserved. This would be the initial of the first or the fifth sector of the disk. Now let's switch to the other system. GDisk dev SDA. As we can see, this one being the newer EFI system shows that they will come with a protective MBR installed, and also acknowledges that it's found a GPT present, or the partition of the system being a GPT, as we found out earlier. It also shows that the size of each sector is 512, and it also shows that the first SDA1 partition starts at the initial of the fifth sector. Even in the new GPT disk, still the geometry looks similar. Now, the protected MBR is, as I understand it, is a new. It's now managed by newer tools, and it basically simulates that anything that reads older legacy code, MBR code, is going to see the new disk or higher, a disk of bigger than 2 terabytes as just one huge partitions. This is not relevant for the day-to-day operation. This is just relevant to find out what it is. How do you identify systems that had been loaded with EFI or BIOS legacy? So as we can see, in both legacy and EFI, the first 4 sectors are reserved, and this is how we can tell. Now let's look at the specific for the boot partitions. As we can see, we find that grub is involved as one of the group loaders of the system. And also that the newer systems are utilizing this methodology to load the kernels from this location. This is in the EFI systems. Let's move to the legacy one. The legacy one, as well, as we can see, is also utilizing the loader entries. Let's find out the grub. And grub points to etc grub 2 points to this location. Let's move to the difference with grub and the EFI system. Now, the tools that we have available for grub would now be these extra packages. And this one we also have the same ones, but we don't actually do need these ones. For example, the EFI, we don't need it. The hardware configuration for the EFI system looks like this. This is a VMware picture, a VMware example of the motherboard type of booting. This is how it looks for the EFI. And this is how it looks for the BIOS legacy system. As we can see, the firmware for the motherboard allows for this, and this is the BIOS style of booting, the older or legacy one. This image shows as well a different system. This is a physical system, and also displays the typical style of a EFI booting system. The EFI is contained in this one, and it's the FAT style partition type, whereas the more traditional one is a Linux type of partition. This is how the potted tool shows the disk of the booting. It shows that it is the type of partition table is GPT, as explained earlier. The size of each sector is 512, and it does start at. It doesn't show the sector. This is by size. This is not showing the sector view output. This again shows the grub2 packages that are required for the EFI booting style. This image also displays a typical installation with when EFI is being used as a method for booting this system. We are also not finding any more entries of the kernels directly in the configuration of the graph configuration, like in this picture. This one, while is a system booting EFI, it is, in this case, is a Red Hat 7 starting from Red Hat 8, maybe earlier. We now no longer see VM Linux entries in the configuration directly. Instead, it has moved to /boot/loader/entries, like we saw in like we can see in this picture. Boot loader entries. So graph config is loading entries from this, its code directly from this location, starting from Red Hat 8. This is what we can see inside each one of those, for example. The entries that we used to be with the very basic parameters, we now have them under bootloader entries. This is how a physical system looks when booting in the boot mode is in UEFI. This is how a Hewlett-Packard based physical server looks when booting in legacy BIOS. This is an example of how do we change the booting mode in a Hewlett-Packard server system generation 10. As we can see, there is the UEFI mode and legacy BIOS. Here we see on that physical system from earlier the view from, instead of size, we see it in sectors. So this one being the first SDA partition, it starts from the 5th sector of the disk. Again, the size of each sector is 512 bytes. An interesting helper as well is the tool file. When we run it with -s, is going to try to identify the type, the nature of the partition, and as we can see in this EFI disk or system, it identifies the partition number 1 as being a FAT type and boot sector. Similarly in this one, being an EFI system, we can see it identifies the partition 1 as being MBR sector. The second one being a traditional XFS file system. Again, let's watch at the distribution. First one is a boot system, EF5 on FAT, and the second one being the traditional Linux file system. Let's go back to the legacy one, do the same. It just says it's a DOS MBR sector. See the distribution of the disk. We only have one physical partition in this one. This is the type of partition. This is how I wanted it in my failed attempt to make a hybrid booting. Meaning that if I somehow manipulate the partitions on the system, on a given system, I would be able to easily switch from legacy boot to UEFI booting methods and boot either or. So this is how traditionally a system looks when it has been installed by default on EF5. The partition comes with these codes. When I inspect the disk, it says it definitely identifies the traditional protective MBR on the first sector, and then it says that the disk is prepared as a GPT, which is what we want. But the information I found in line suggested that the boot for legacy BIOS has to be this one, EF02. So I would have a chance to boot from it. So I wanted it to basically tell the operating system that this one is a bootable legacy partition. So I went ahead and modified the partition number 2, changing the code to EF02, and this is how it looked. EF2, and then I brought the changes to disk. Then after this I followed with part prov to tell the operating system that the partition to inform the operating system that the partition table had changed. This is how when you use parted, this is how it looks. It now looks with the correct flags, with the correct file system. So in theory, I should be able to boot from it. Nothing else has changed, only the type of disk, the labeled. How I understand it, that even though it was a GPT partition table, that the protective MBR would be hit by the original loader, and then it would show the big disk as a 1. But I was wrong. That didn't happen as I expected it. This is how it looked. Before this one, I ran the part probe, let the system know, rebooted. It was unable to find the booting as I expected it, so something else clearly was missing from my approach and from what others have done online, but I was unable to. So I attempted to override the main disk MBR with this traditional i386 PC, which is the way you indicate to burn basically the first sector of the disk with the traditional i386 code. This is how you specify for BIOS legacy. Instead of this, there is the x86_64, which also would do the same, but would be for EFI system booting a traditional BIOS partition from a BIOS partition. That also didn't work. This is again just a indication how it looks and how it should work. Same, but with the correct codes. That didn't work. Essentially what I concluded is that we would have to choose either or. Hybrid booting is not advisable. It has complications when your kernel comes into the picture and you continue to maintain that system. So if you do install it either on BIOS legacy, you keep it and maintain it on BIOS legacy, but ideally do not move it up to GPT while still keeping the system untouched. Or if you originally install it in EFI, then you keep it like that and you maintain it like that, but you don't go from EFI to BIOS legacy or from BIOS legacy to EFI. Although there is documentation of people moving back and forth between them, what it looks like is people are doing is that people are upgrading MS-DOS partition table to GPT just to maintain to upgrade a system that already, either because a disk failed and now new or bigger disks are available, and so you don't have to reinstall the system again. So it is possible, technically speaking, as it is documented on internet, to still have a traditional system that has been traditionally installed as an MS-DOS system, as a BIOS legacy, and upgrade it to EFI and still keep maintaining it like that. But the other way around, from EFI to BIOS legacy, is not advisable. That's what I've seen. That's what I've seen as we move from Red Hat 7 to Red Hat 8, now Red Hat 9, and based Red Hat system as in Rocky, Linux or CentOS or Fedora. This is what I've seen, the trend that I've seen. This recipe is basically how do we manage to rebuild a disk that used to have the information for booting the system, but it was an EFI disk or GPT. So basically, we boot with an emergency Linux. We put into it. We load we load the older systems into the recovered system that has lost basically the booting information. We bind it to the memory file system requirement file system into the system, and we change root into it, and we run. Well, we remove this information which is now not updated because the disk has lost. We lost the disk information, and then we reinstall these packages, rough, EF5, and common. This has essentially a scriptlets that run and recreate this graph information for us in the newer EFI installation. So this is a recipe that I didn't want to put out there as to how we recover or restore a booting information on an EFI disk. As indicated earlier, my whole goal was to implement a system with a hybrid boot style. It is said by Google by hybrid MBR, and Google said that we could boot a GPT disk into legacy BIOS, but it requires a special configuration with the BIOS boot partition. That's what I tried to do, as it is explained, but it didn't work. So something else is missing, clearly missing. That is not, it's not working out for me. So yeah, and then Windows, but Windows, I don't care at this time. I don't have a hybrid operating system that I want to boot. I just want one operating system to boot from legacy BIOS and EF5 style. That didn't work out. And this is the best guide that I found in internet and what we should do instead of going from UEFI back to legacy. I think that what this article is explaining, is that we should be moving from legacy to UEFI without needing to reinstall the OS. With just a few tweaks, we should be able to modify the disk to upgrade it from MSDOS partition table to GPT table. And in this article, it explains very well how you get that without have to reinstall the OS necessarily.